Hello, today we will be talking about switches and routers and some of their capabilities that allows them to function in a network. My name is Daniel and I am a student of computer networking. My interests are in learning about the latest up-to-date technologies, and I have recently become interested in the cloud. One of my hobbies include enjoying the outdoors. Others activities are hiking and sightseeing. Currently I am an intern at Virtually Testing, learning more about computer networks in general. Our agenda today is to first talk about switches and their functions, such as creating VLANs, and we will be able to examine MAC tables. Next would be routers, where we will discuss the purpose of subnets and examine its ARP tables. Finally, I will introduce you to my network design activity using the content in this video to create a small network. The design demo will be in the following video. First topics are switches. In this category, we will discuss what a switch is, how switches can create VLANs, the MAC tables it creates when functioning, and lastly, we will compare the difference between a managed and unmanaged switch. Well, what is a switch? Switches are network hardware devices that allow communication between devices in a network. They are mainly used in local area networks, and most importantly, they can be used to create VLANs, which we will discuss later. Some common switch manufacturers are Cisco, Netgear, and HP. In the most enterprise environments, you will most likely be encountering the use of Cisco switches, and we will have a demo in using them in the next video. VLANs are a big topic, but a generalization would be that they are used for better performance in networks, and it helps direct traffic to the location easier. VLANs improve security because they are able to isolate groups logically. This means that VLANs would be looked at as if they were in separate physical locations. There are many different types of VLANs, and the default one is called a native VLAN. All interfaces on the switch are automatically set to this VLAN. Communication between VLANs need to happen on a layer 3 network. This is either by a layer 3 switch or router. Best way is to set a communication interface to a trunk port setting to be able to talk to different VLANs. Here we can see different VLANs indicated by different colors. Blue is VLAN 100, yellow is VLAN 200, green is 300, pink 400, and red is the VLAN 500. Each of these are logically separated, but look physically together. For example, VLAN 400 and 500 are seen by the switch as completely different domains. To communicate from VLAN 400 to 500, it would need to first send the packet to the layer 3 switch, and then to the router, and then back down to the VLAN 500. And as you can see, the trunk port here, it is used so it can communicate with all the VLANs set for the trunk port. It is not set to a specific VLAN as the other ones you see in this picture. I will explain more in the demo, exercise next video. Now moving on to MAC tables. MAC tables are a layer 2 category. It does not need IP addresses because all it does is determine what MAC address belongs to what port and where to send the data packets back to. What it does is that the switch learns about the device and adds it into their memory cache, so they would know where to direct packets next time it is sent to that location. Initially, switches do not have any idea of which port belongs to which port. This is why switch needs to learn the different path to take the first time around, and eventually they will have their MAC tables filled. Here is an example of the show MAC address table command on a switch after it has learned of all the possible directions. There are 4 categories: the VLAN, the MAC address of the destination device, the type of direction, and the port number. The VLAN is what you set the port number as. If not set, the default is the native VLAN, which is 1. The MAC address is either dynamically or statically assigned. And lastly, the port number of each destination MAC address belongs to, for the switch to send the data packets in that direction. Now moving on to layer 3 switches, also known as multi-layer switches because it can function in both layer 2 and layer 3. Essentially, layer 2 switches are just port to MAC address, and it only performs switching. It has the advantage in speed if the data packets being sent to the destination does not need a layer 3 device to route the packet to the destination. The difference between a layer 3 switch is mainly in routing. If the destination device needs to interact with Subnet or another device on another VLAN, the layer 3 switch would come into use. We'll talk about layer 3 more in the routing section. Now as we move on to routers, we will discuss how VLAN communicates with other VLANs, then talk about subnets, and I will show you how the ARP table works in routers. Let us begin with what is a router. Routers operate in layer 3 OSI model at the network layer. This helps them communicate between networks. If anything related to subnets or VLAN communication, it is done through the router. As you can see, there are some common router brands in the industry today, from Cisco to Juniper to Nokia and HP. Onto subnets. Think of subnets as a subnetwork. You want to divide the networks up to have more organization. In a way, subnets are analogous to VLANs because of their security, organization, and partitioning. One big difference are that subnets operate on the layer 3, as to VLANs mostly operate on layer 2. And as usual, if networks are organized, it allows them to perform better and have data delivered more quicker. Here's a subnet cheat sheet that determines the total amount of network addresses that there are and how much hosts can be in each network. On the left, you could see the CIDR notation. And in the next column, you could see the total number of addresses that are available to use. The next column, you see the amount of host addresses, which is always 2 addresses less than the total number of addresses, because the first address is used for the network address and the last is used for the broadcast address. In the last column, you can see the traditional way of writing a subnet. Now on to ARP, which is also called Address Resolution Protocol, which is similar to MAC tables, but instead of interface port to MAC address, it is IP address to hardware MAC address. These here are 6 fields that are shown in the router's ARP tables: the internet, address, age, hardware type, and interface. In this next slide, I will go more into depth. Here's a picture of the router's ARP table. You see the ARP command that was used in enable mode. Now first is the protocol, which is most likely always to be internet because the layer we are working in. Next, you also see the IP address to the MAC hardware address. Then you see the age, which the router determines whether or not to keep the route direction in its cache. Usually after 240 minutes of no routing in that interface direction, the router clears the cache for that specific direction. Next, you see the type, in which this case is ARPA because of Ethernet connection. Lastly, there is the interface port, in which is the route to data. Now moving on to the packet tracer activity I will introduce in more depth next video. We will be working with VLANs and subnets, and the communication between layer 2 and layer 3 switches and routers. Here's the setup design. We will be working with a network on the left and a network on the right with different VLANs and subnets. On the left, you can see 2 hosts with different subnets, and in VLAN 100, on the right, you can see 3 hosts with different VLANs and subnets. Next video, I will demonstrate how they can all communicate with each other. To finally recap, what we did today was talk about switches and routers and their configuration and abilities to function as part of a network. And I finally ended with a small introduction to what I will demonstrate on the next video for my packet tracer lab. Thanks for watching. I will see you in the next video to demonstrate a hands-on activity.